So we're talking about robots, in particular mobile robots, and I hope that we can overcome some of the depression that was created in the first session this morning, where we learned how terribly bad we're doing with sustainability and efficiency and productivity. But actually, before showing a little bit what is possible today with robots, create depression even bigger. We're also doing terribly bad in safety. We have labor shortage issues, and I think for all of these aspects, robotics can help quite a bit to make us better in that sense, but also to open up new possibilities. So new ways in how we can do things, new ways or new products that we can actually create on construction. I try to distill this into different subcategories of what are the pain points that we see on construction side and where robotics might help in the future. First thing is that everything keeps slipping. People don't show up, material doesn't show up. That means like pretty much all the construction projects have delays, so 70% of them. It's super hard to collaborate. So you have subgroups and they have very limited communication in between, which means also there we can improve a lot because robotics helps us in distributing data significantly better. There's very limited project insights that we're typically having, and there's a lot of wasted time. There's a lot of waiting on construction sites, and we heard it from Ryan before. If we know at what exact time I'm done with my job and I can call in the truck to do the next job again, I think that makes us a lot more efficient in the longer term future. Now, if you look at other industries, they have overcome these issues quite a while. If you go to manufacturing assembly, you see images like this, dozens of robot arms that create products completely automated, so we have no humans in these environments, and that literally helped us to make things cheap, but make it also much more precise and in exactly predefined timings. Now, if you take this paradigm and just move that to the construction world, you would essentially end up with something like this. So this was an example where some of the research was done by colleagues at ETH and then later commercialized through, for example, the company Elne, where the same kind of technology using robotic arms is used in order to prefabricate certain aspects. This prefabrication here was used in order to build up a roof of that building. We're talking here about 500,000, 1 million nails, about 50,000 timber slat, which means if you would do that by hand in this exact geometry, it's almost impossible. And only robot technology allows us to do this. Now, the title that I had in the beginning was talking about mobile systems, which means instead of like having a gantry system, what we want to do is we want to make systems that are moving around. And that's not something new. So if you look what exists today, you find products, for example, Hilti J-Bot, which is moving around and drilling holes. There's many other in that field. They are used for different type of applications. Here again, a few examples of what is done today. That's more from the research perspective of some of our colleagues at ETH and us doing bricklaying, mesh molding, or in this case, concrete spraying. And it's not only about doing jobs that we do today, but do it in automated fashion. It's also about doing things in geometries and shapes that we could not do in the past. Here are a few examples of that. How you can make like super nice brick walls with nice shapes, acoustic walls. You can make plastered walls and they're not flat anymore, but they have nice structures inside. But again, if you're looking at this thing, this is not really mobile robotics. If you ask a robotics researcher, they will tell you, well, that's a quasi-stationary system. You just move it around and then you have it operating again. And I think that is just limited in terms of capabilities and in ways we can scale it. If you're talking to the robotics colleagues today, then the vision looks much more like this. And that's an illustration from Apptronik, a US company, where we see a couple of humanoid, legged systems, all kinds of systems working on construction side. It sounds like a weird fantasy thing, but it's not something that is that far out in the future. If you distill this a little bit and see what is actually possible today, then we already have machines that help us for quite a number of tasks. So construction progress monitoring and verification today is possible to do it in an automated fashion using mobile systems that move around, that generate 3D scans very precisely that generate pictures, which can be used in a lot of backend softwares in order to do verification, in order to do BIM comparison, and also help with a lot of soft factors like site simulations, simulating what is the current progress, and also safety constraints. Now that's one thing which is today, and today already implemented in some innovative environments. I think the future goes a step further, where we're going to have mobile systems that help us do the job. And that means we can have systems on job sites which may work with superhuman precision, which allow us to increase job site safety and also increase kind of the scalability, because they're just permanently available. And if we need 2, we get 2, and if we need 10, we get 10. We don't have to go on a job market and find people and ask them, please, could you come tomorrow to work? Here is a short video of some of our colleagues that are here in the room, so it's a good coincidence by Boston Dynamics that shows how this may look like in the future. I mean, you have to know this is not something that works all the time in any kind of construction environment, but it shows where technology stands and what in principle could be possible today. So this is Boston Dynamics Atlas working on a potential construction site, and shows you how it's using hands to move objects, how it's mobile enough to work in such environments, in a kind of artificial case where a guy is calling it in order to bring up some tools. But I think it's a very nice illustration of what might be possible in the future. Questionable whether you have to do these kind of things on a construction site, whether they would even allow you to do it, but it's a cool demonstration of capabilities. Not all construction workers can do this, probably. And I think there is 3 main elements that are happening today which make this video not kind of an utopic future that might happen in 100 years, but something that is coming to reality rather soon. First of all, there's multiple, and not only saying like the small companies and small universities doing things, but large players coming to market with mobile systems, whether it's quadruped or humanoids, and that makes it ubiquitous and available, and suddenly many people can build upon that. Second thing is, I think we have made tremendous progress on the machine learning side to make these systems much more capable, both for mobility and interaction. And a third aspect is that construction surveillance, which was a separate topic, and SLAM has become at the level where these things are melting or are fused together, such that we can really use robot technology in order to do all the construction surveillance necessary. First point, so this is just some illustration. Last 6 months, the humanoids that were released in this time. If you go to the quadrupedal world, it's even a step further than this. They're not only released, but there's hundreds or thousands of them in the field today. I personally have worked with this guy for many, many years. What we do normally with them is that we have them operating on industrial facilities. And there it's kind of a commodity in the meanwhile for many of them, have these systems moving around doing industrial inspection, monitoring of what's happening. You see them equipped with a bunch of different sensors. You can actually go, on your left you see there's a digital world where you plan the whole routine and everything, and then you have the robot executing this on the actual facility. And that's the thing that also will become possible in the construction sector in the near-term future. Second thing, making systems much more mobile and much more capable. We have been working for about 5-6 years on using machine learning, in particular paired with simulation, in order to train advanced mobility skills for these systems. And the cool thing is, in the meanwhile, there exist tools that allow us to take a laptop, simulate thousands of agents there. After a few minutes, you get a policy that you can really put on the actual real-world system. And what you do here is, the better the robot becomes, the harder make the challenges, and so on and so forth, and you grow the skill sets like you have a human getting better over time after they were born. And today we're able to have these machines moving around in pretty much arbitrary environments, whether there is different obstacles, geometric obstacles, natural environments. They're super robust, so you can start pulling and pushing them around on slippery surfaces with unknown obstacles, and they're just not falling anymore. So we're testing actually these systems very often in like some of the harshest environments you can think of. And since we had a lot of reusing materials of collapsed buildings in the morning, here's an example of how these machines can deal with that. We're not transporting it around yet. They're too weak for that, but at least it shows you a little bit what these capabilities are. And I want to do a bit of a deep dive here and show you where these technologies will be going. I assume you have problems like this. You want to have a system that can do a complex maneuver like you've seen before in the Atlas demonstration of jumping on a box. And you want to do this not only for jumping on a box, but you want to do this for different types of environments. You can train that. We learn it in a simulation in how you can execute this jump on a box. You can train how to jump down of a box. You can start doing different maneuvers like getting across a gap or getting underneath a certain obstacle. And then you let the system combine all of these technologies. And again, we do this purely artificial. In a simulation, you let it train, play around with different environments, and you just make that with thousands of robots until you have a skill set that literally allows you to do all of these maneuvers in the real world. And to show you that this is not only one pre-planned maneuver that once in 180 times works, it's super dynamic. So you move obstacles around, the robot will react to that, overcome this. So I think in the very near future, we're going to have the mobility level solved that is necessary to work in a construction-like environment. Here's an example of how we're building up this in a natural environment. So this is at the lakeside in Zurich. You go there, pull up a couple of boxes, and you tell the robot, go to the other side. And it'll figure out the way and how it navigates this challenging parkour, localizes itself, figures out the maneuvers to trigger, and executes that. Now, what I've shown you so far is the mobility aspect, getting around the environment. We have to do a lot more. We want to have systems that become actors. I think that's the next bigger step. We are still, if you look at the research on the versatility side, on the manipulation side, the gap between what humans can do and what robots can do is still huge. Nonetheless, for operation with several tools, we probably get to a level where this is sufficient. So here, what we do on the left side is manipulating doors and environments where we're going to have these robots being deployed. What you see on the right side, give it a tool, in that case a drill hammer, and let it execute a certain task. So that's kind of the J-Bot solution, but instead of having a 400-kilogram tracked vehicle that you have to take with an elevator to the upper staircase, you have a mobile device that can move on a scaffold and drill the hole at the right location at a much cheaper price. Now, what is missing is that you have to combine this manipulation skill with high precision, and that's kind of the last element that I think has emerged to a level where it's becoming super useful for construction. So these robots are all equipped with LiDAR sensors, stereo cameras, and many other sensors. But what is relevant is that they can fuse this sensor information while moving around to create 3D maps and to localize within these 3D maps. And these 3D maps, they are not that imprecise anymore as they used to be a couple of years ago, but even with automotive-grade systems, you're going to get to a few centimeter precision, which for a lot of construction tasks globally is more than sufficient, and then locally can do high-precision measurements in order to execute, for example, drilling a hole. And you can use this technology in order to digitize construction sites. So here is the combination of the quadruped equipped with a Leica sensor that moves around, creates a 3D map. And now the super cool thing is, what we're doing here is we are creating a loop that we can close. So we have a robot that moves in the real world, that creates a 3D map of that real world, that can digitize that, and that can train again the behavior in the virtual world and execute this on the real world. So if I get a BIM model of an environment, we can train the robot to move to an arbitrary place in that virtual world, and you go and deploy it in the real world. You create the data in the real world, and you feed that back into your simulation pipeline. So this simulation execution is becoming kind of an iterative loop. And you can do this in small scale, like we did this in one building, in the physics building where we had the construction workshop last year. But you can also do this in larger scale. So get them moving around, through parts of the city, digitize that, and then use this digital world again. In this case, it's a quadruped with wheels, but it's the same type of principle behind that. Now, this enables us to deploy these systems today. What we have here is pretty much what I showed you before with the industrial inspection, but applied to construction side. So machines that move around, that map the environment, that help generate the data necessary for this information necessary of the construction or the job site managers for safety-related questions, for job site management tasks, etc., etc. You can also use this technology and then go back to what you have collected data before in the past, go through this in the evening, have the job site manager scrolling through the site and see what has happened in the past. And with this, my last 10 seconds are here, and I'm stopping. Thanks a lot for your attention, and enjoy the last part.